All right, so our next standard is looking at Q features given a graph. We will focus mainly on quadratics this year, but realize that all of the things that we're talking about could apply to other graphs. Just for what we're going to be testing on, though, will be quadratics. And so as we look, a lot of these things you've already done with exponentials, so in secondary one, and with absolute value functions. And so it's very similar in the fact that we're still looking at our graph, and based off of our graph, we're going to be pointing out a couple key features. And so as you look, notice we've got domain and range. Remember, domain are our x values. So I'll just write that above. Okay, so our x values that are used for this function. Our range would be our y values that are possible. Our x and y intercepts are where they cross the x-axis and the y-axis. So I'll just say cross. Your vertex is that change of direction spot. So I'm going to, it's going to be a point where the direction changes, and we'll look at that a little bit more. And then you've got your end behavior. So what happens at the endpoints? All right, so you have your left side, what happens, and you have your right side. And you're just looking to see, is it going up? Is it going down? Is it staying constant? So as we're looking at this graph, again, a couple of things we want to keep in mind. Remember that when you have a function, unless you have a dot at the end, it goes on forever in both directions. So notice that if I was following this from left to right, I really have, my graph is continuing up here and it's continuing up here, like forever and ever and ever. So when I look at my x values, I am always able to come down and hit a point on my x-axis. And so because of that, because you can always hit a point on the x-axis, that's going to mean that your domain is negative infinity to infinity. So, and that's usually the case for most functions. You have negative infinity to infinity. This is always true for quadratics. The only other time that it's not negative infinity to infinity is if you have like a square root function where it's bounded, which means it has a starting point, or if you have a function that's bounded, that's got endpoints. Your range then is where do your y's start. So as you're looking at your graph, notice that my graph is basically around here and up. So when I look at my points, that wasn't the best line, but notice that my lowest point right here, like I have nothing lower than that point. So there's nothing below the value of -4, which means everything's above that. And so -4 is an actual point, and then it goes up from there. So my y values, -4 is the lowest y value you can have, and then it goes up forever. When we're looking at intercepts, intercepts again are where does it cross the axis, okay? Whether it's the x-axis or the y-axis, and we name the point as a point. So when I'm looking at my x-intercepts, this is an x-intercept because it crosses the x-axis there, and I name that by going 1, 2, 3, 4, 5. So that's the point -50. It also crosses at this point, which is -10. So those are my x-intercepts. But you also have a y-intercept. It crosses the y-axis at this point right here. And then we name that point over 0. And then it's going to go up 1, 2, 3, 4, 5. So 0, 5 is your y-intercept. So y-intercept, just so you know, and then these are your x-intercepts, okay? And a lot of times we just ask for the intercepts, and the intercepts are both, right? We just want to find out where does it cross. Those are key features that help us graph. All right, and then you've got your vertex. Your vertex point is the highest or lowest point of a quadratic when we're talking about quadratic. So in this case, I want to know what this point is right here. Okay, so we said that we knew that it was -4. That's the lowest y value, but then I come over, and this value right here would be -3. And so my vertex is the point -3, 4. Now, as you look at that graph, I just want to talk about that a little bit. This little imaginary line right here, notice how it cuts my graph in half, or it makes it so it's symmetric on both sides. This is called the axis of symmetry. I know that it doesn't ask for that right here, but that is going to come up again, so we might as well start talking about it. The axis of symmetry is the x value of your vertex. And it's just that symmetric line, so everything on both sides is the same distance. So what I want you to notice is, like, here's my axis of symmetry. This is 2 spaces to the right. This is 2 spaces to the left. And it's always going to be that way. So you'll notice if I was looking at if I was looking at these values right here, this value right here is the point, that's our y-intercept. So that was the 0.05. But notice on the other side, I have a point exactly in the same spot. And it is going to be at, let's see. So if that is -5, so this point would be -6 and then up 5. So again, if this is 2 over 2, or no, that's 3. If this is -3, then this would be 3 spaces over to the 0. If this is -3 and you're going over to -6, this is 3 spaces. And so that's always true. It makes it really nice. That axis of symmetry keeps everything symmetric or equal distance from that line on both sides. Not that it's asking, but it's good to know. And then you have end behavior. And so the end behavior is what's happening at these endpoints. Okay. So it's basically saying when x is getting smaller, this is your left hand. Okay. So as x gets smaller, what does the endpoint do? Well, in this case, the endpoint is going up, which means it goes up forever to infinity. As x is getting bigger, or as x approaches positive infinity, that means what happens on the right-hand side. And on the right-hand side, your endpoint, again, is going up to infinity. All right, with quadratics, your endpoints will always do the same thing. So your end behavior should be the same. If you're looking at different types of functions, like if I was looking at a cubic function, then my graph might look like this. And so this is my left end behavior and it goes down to -infinity. And this is my right end behavior and it goes up. Okay, or it could be flipped, where this is my left end and it's going up, and this is my right end and this is going down. But this is a different type of function. So with quadratics, we always have them facing the same direction.